All right, so I think this is recording. Let's take a look at this problem. It's a quadratic inequality. We'll do it by two methods. We'll do it algebraically by finding our critical points, picking test points, organizing it in a form of a table, and then shade the different regions that are critical points, divides our number line into three regions, and to shade or not to shade each region. And then second, we'll graph this function, this quadratic expression, which is a parabola, and we'll look at that parabola and see what portion of the parabola that we want, and then describe the x-coordinates of that parabola. So let's first do it algebraically. In either case, we're going to start out by factoring this. If we place our x off to the side, we've got negative 5x on the bottom. We've got negative 6x squared on the top. If we have two values that when multiplied together give us the top expression, but when added give us the bottom. This factors, because the leading coefficient is 1, I don't have to come down and chart it. I can just use my coefficients of x plus 1 and x minus 6. So set these individual factors equal to 0, and this gives us our critical points, and that divides our number line into three regions that we can label A, B, and C. So our first decision on our critical points here, on these endpoints, is whether to leave them hollow or to shade them in. That's determined by our inequality. Since the inequality was not underlined, we don't include an equal sign. We do not shade these in. We leave these hollow. So let's pick a test point from each region, a number that's smaller than negative 1, well, I'm just going to pick negative 2. A number that's between this negative value and this positive value, I'm going to pick 0. And a number that's bigger than 6, I'm going to pick 7. So I'm going to make a table to where the first column, call it a test point or call it the region. The middle column, you can use the original expression or the factored expression. I float back and forth sometimes between the two. And then this final column, I'm just going to call it my truth column. It tells me whether to shade or not to shade my region. So in region A, we suggested picking a test point of negative 2. So if we replace x with negative 2, I get negative 1 times a negative 8. That's a positive 8. But 8 is not less than 0. That's a false statement. So I'm not going to shade in this region A. In region B, I suggested using 0 as a test point. 0, 1s, and negative 1s are generally easy to do arithmetic on, so I like to pick them if possible. Now, I can never pick my critical points as my test points. Be careful of that. 0 minus 6 is a negative 6. That product is negative, and negative numbers, it's true that they're less than 0. So this middle portion is going to be shaded in. And then in region C, I suggested picking 7 as a test point. 7 plus 1 is 8. 7 minus 6 is 1. This product is 8, but 8 is not less than 0. That's a false statement. So we're only going to shade in this region B. It's this interval of points that if you replace it with x and do the arithmetic, the result will be a true statement. Those values will be less than 0. So to describe that in an inequality, I'll just write it negative 1 is less than x, which is strictly less than 6, and call that my final answer. Now, let's do the same problem, only using analytic geometry, sketch the graph. If we have the graph of a quadratic, it's a parabola. With a leading coefficient that's positive, my parabola opens upward. So I have a parabola that opens upward, and our critical points that we called over here are really over on the graph, the x-intercepts Now I haven't keyed in the y axis, but I really don't need the y axis. Now I probably should emphasize that these are not included, so make them hollow, and these x-intercepts of -1 and +6. So now I look at the inequality and say, what portion of the parabola am I interested in? Being this is strictly less than 0. Being less than 0, I'm interested in the part of the parabola that's below the x-axis. So I'm interested in this portion of the parabola, and specifically, I'm interested in the x-coordinates on that portion. So these points that are in the shaded region, where are their x-coordinates on this number line, on this x-axis? Well, they're up here. These have x-coordinates there, so they're in the middle, and I shade here. And so when I describe this, I've got -1 is strictly less than x, which is less than 6. And that's the same solution set that I got with my table. So different students have a preference for algebraically or visualizing the graph and what portion of the parabola you're interested in, and then describing the x-coordinates of those points. So hopefully this helps. Don't be afraid to ask questions, and I will talk to you later. Bye.